what we are going to do, we have number of courses and prerequisites, and our goal is to see if we can finish our courses, all those courses. So there are some prerequisites in the case that we must take course B if we want to take course A. So let's solve this problem. This is a topological sort, so we need to, the way we are going to solve it, we will count our in decrease number and for given vertex, and also create our adjacency list, of course, from parent to its children. And what we are going to do is like go all those over all those vertices, and basically in the beginning, so we will count all those in decrease, the relationship between them, and every time when we process our we will do BFS, and every time when we process a given vertex, we will be just removing its removing it from our um, dependency graph, and then from there update all those vertices, and then it's like every time when it has 0 vertices, that means the prerequisites for the given course is complete. So we will just count how many of them we have removed and then compare them. So just jump on this right away, and let's create our hash map. It will be an integer and list of integers. So this is a graph, new hash map, and hash map integer. So integer, because like we will be counting our in degree values for given vertex. So in our vertex is integer type, and the first map it's our adjacency list, and for I0, I negative num courses, I plus plus. Okay, we will put in degree, put I, and first time all of them will be just 0 in degree, and we are going over this num courses, and then it's like taking each of this I as a course number and giving it 0 in the initially, and then sometimes there could be no prerequisites for given courses. So in that case, like all of them will be just 0, and when we are processing every single prerequisite from our queue, it will be a BFS. Then the count will be same as this num courses, and it's like, so we can say it's like we finished in time for this num courses, and we can finish all of them. And now let's go over our prerequisites. So for prerequisites, requisite, and they will be prerequisites. So int parent, so let's define our parent from our prerequisite. So our parent, so you must take course B. So we need to take course B if we want to take course A. So we can say that course A contains this B. So for given vertex A, these are some prerequisites of its children. So we can say for A it's our parent, and for B it's our child. Okay, now what we are going to do, we will be creating this graph basically. So compute if absent for given, we can say let's do child first, child. So val initially is just like empty array list. Okay, and for its graph, compute if absent. So for it's a directed graph, so from parent to child. add child. So compute if absent hits, since it's a directed graph, we go from parent to its child. Now in degree put so since there is a relationship between parent to its child is taking one, it will get incremented, it's in degrees because there is a dependencies from parent to child, so we can actually increment for given child the in degree count. So child plus 1. Okay, now let's create our let's do the BFS traversal, so we will need Q for it, and this Q will only hold vertices which don't have any in degree values. So now for map for each of these entry in our given in degrees, we will be traversing it and getting vertices that do not have any in degree values. So entry in our in degree entry set. So let's see if this entry get value equals to 0. Then when it equals to, then we will add to our queue entry get key. Okay, now we will just traverse while our queue is not empty, and then remove this vertex out of our queue which doesn't have any in degree values. Remove first, then I mean, since we removed it, we can actually do our count, so we will be counting it, and then because we will be comparing it to how many times we have removed this vertex which doesn't have in degree values, which means there is no prerequisite for it. So, and then in the end, we'll just compare it with our number of courses. Now let's go over our other vertices in its child. So in our graph, that's the value that we have. So for given vertex, we'll try to get it. If not, then we'll just have array, empty array list basically. So we will not go for this loop. So now what we are going to do, we will decrement, because like we have removed this vertex. Now in our in degree graph that we are keeping track of this in degrees, we will just decrement the value because we have seen this value for it. So in degree v and negative 1. So now also it's like every for this in degree value, if the vertex in degrees is 0, then we will add to our queue this given vertex. So in the end, what we will be doing it, we will just return our count that we were counting all those courses that we can finish it with our, what was it, num courses. Let's run our code. Oh, get, there you go. So let's submit it. Nice. So as far as for time complexity is O V plus E, where V is all those vertices, E is all those edges. And For space complexity, we are using this graph in degree. We're also using this deck, and we can also say this is also O v plus e, where v is all those vertices, e is all those edges.